Hello and welcome. We're going to take over these 6.2 notes, properties of parallelograms. So I'm going to first zoom in on the idea that if a quadrilateral is a parallelogram, then both pairs of opposite sides are parallel. So our picture for that would be something along these lines.
Hello.
Hello.
I forgot my phone because I
You
didn't
really
eat.
did. So that means those ones are going to be parallel, and these ones are going to be parallel. Have a nice day, bud. Okay, so that is our definition of what a parallelogram is. That is what it is. But there's other things that happen once we lock in on that being true. So one of the things that is also true in a parallelogram is that the opposite sides are congruent. And that means both pairs of opposite sides are congruent. So here and here, oops, not parallel again, but instead they're going to be congruent to each other. The opposite sides are congruent to each other. So that's one other property. Another property of parallelograms is that the opposite angles are congruent to each other. Couple more here. We have that the quadrilateral is a parallelogram, the consecutive angles are supplementary. Now, this actually has a lot of pairs to it. So that means that every green angle is supplementary with every black angle. So we could look at it, these two as consecutive. We could look at these two as consecutive. We could look at these two or these two. And in any of these cases, the quadrilateral being a parallelogram means that the consecutive angles, any pair of them, are going to be supplementary. This stems exactly from the fact that if we had parallel lines, because the property doesn't go away, if we had both pairs of parallel lines, well, these are consecutive interior angles cut by a transversal. Therefore, the consecutive interior angles are supplementary. So, in a thought, parallel lines leads us to consecutive interior angles congruent. Okay, so there is that bit of information. The new part to us that we really need to drill down on is the fact that the diagonals bisect each other. So that means that these diagonals are going to bisect each other, not necessarily that each one of these four pieces is congruent, but that these two are congruent as well as these two. All right. If an angle is a parallelogram, if one angle in a parallelogram is a right angle, then all four angles are parallelograms. So let's think about this. We've got our parallelogram, we'll show it with the parallel lines. And then I make one of these a right angle. Well, its opposite angle must be congruent, therefore it's also a right angle. What about the supplement? What's the supplement of 90? Well, it would also be 90. And the supplement this way, that would also give us 90. And so once we have one right angle in a parallelogram, we actually have four. And that's one of the theorems that we have. One of the other theorems we have is that if we take a parallelogram and we put in the diagonals, well, we're already starting with the opposite sides are congruent. And we're also saying that these bisect each other. These diagonals bisect each other. And so we have four triangles that are each 1 marked, 3 marked, and 4 marked. We have three sides here that map to any three sides of any of the other triangles. So basically, triangle 1 is congruent to triangles 2, 3, and 4 because of side, side, side congruence. Side, side, side congruence from both pairs of opposite sides congruent, and also diagonals bisect each other. Alright, on to the next page, please. Find the variable. You go ahead and try this yourself. Pause me in 3, 2, 1. Alright, and you unpaused me. Alright, so we've got that x plus y equals 4. We know that 5x minus 7y equals 8 comes to us because the opposite sides are congruent. We know that this angle is also a squared, and we know that this angle 3b minus 2 equals 80 because opposite angles are congruent. So they give us 3b equals 82, and b is going to be 27 1/3, or 82 over 3. We want to work with this in terms of a system, so we're going to have that x plus y equals 4, and 5x minus 7y equals 8. I'm going to multiply this whole row by a negative 5. It's going to give us negative 5x minus 5y equals negative 20. Don't forget to hit all parts of that. Now we're going to add up these two equations to get negative 12y equals negative 12, which is going to give us that y equals 1. Once we know that y equals 1, we can go find a home for that. Like, that's the easiest home. So x plus 1 equals 4, means x equals 3. And I think we still have to find what a is. I'm having a tough time seeing it because all I see is that a squared equals a squared. What we really need to see here is that a squared plus 80 equals 180. And that's going to give us the a squared equals 100 and a equals 10. All right, so there's quite a bit of work there. We got B, we got A, we got Y, we got X. All right, one of my very favorite problems is right here. We're looking at the vertex at the negative 4, positive 3.